let's apply our new definition to the integral from minus infinity to infinity of 1 over 4 plus x squared. And this time our interval is stretching to infinity in both directions, so we have to be a little careful here. The first thing we want to do, since this is a nice function, it's continuous, our definition applies, and we want to split this integral in two at some point a between minus infinity to infinity. And a equals 0 is a natural place to split this integral. So then we have to calculate both integrals, the integral from 0 to infinity of 1 over 4 plus x squared, and the integral from minus infinity to 0 of 1 over 4 plus x squared, and we can only conclude that the above integral converges if both of these converge. Let's start with the integral from 0 to infinity of 1 over 4 plus x squared. It's by definition the limit as t approaches infinity of the integral from 0 to t of 1 over 4 plus x squared dt, which is equal to the limit as t approaches infinity of 1/2 tan inverse x over 2 evaluated between 0 and t. That antiderivative you can calculate from a formula or using a substitution. Now, plugging in the endpoints here, we have that this is the limit as t approaches infinity of 1/2 tan inverse of t over 2 minus tan inverse of 0. And this is 1/2 the limit as t approaches infinity of tan inverse t over 2 minus tan inverse of 0, which is 0. And as t approaches infinity, tan inverse of t over 2 approaches pi over 2. And this you can see from the graph of tan inverse, and it's one of the limits we looked at when we explored the tan inverse function. So our limit is equal to 1/2 pi over 2, which is pi over 4. So the area under this curve between 0 and infinity can be said to be pi over 4. You can either work symmetrically here, or you can calculate the integral from minus infinity to 0 of 1 over 4 plus x squared dx from our definition. And this is the limit as t approaches infinity of the integral from t to 0 of 1 over 4 plus x squared dx, which is the limit as t approaches minus infinity of 1/2 tan inverse x over 2 evaluated between t and 0, but here t is the lower limit of integration. So this is the limit as t approaches negative infinity of 1/2 by minus t inverse t over 2. And as t approaches negative infinity, tan inverse t over 2 approaches negative pi over 2. And again, this is something you can see from the graph. And our answer here is once again pi over 4. However, you could derive this from the symmetry of the function 1 over 4 plus x squared around the y-axis. Now, the integral from minus infinity to infinity of 1 over 4 plus x squared converges because both of these integrals converge, and this integral equals the sum of the finite numbers we got for the integral from minus infinity to 0 of 1 over 4 plus x squared plus the integral from 0 to infinity of 1 over 4 plus x squared. So our answer is equal to pi over 2.